on cellular concepts. Remember, with cellular concepts, there's four main things here. We looked at the cells themselves. They can be different sizes. We looked at the idea of reusing frequency. Now, today, with orthogonal frequency division, multiple access, and other types of modulation today, they don't use the 7-cell reuse. But again, we're just trying to get some of the basics down and to show you kind of how things progressed in the mobile telecom industry. We can hand off as you move from one cell to another cell. Yes, please. No problem. You're not seeing the slide. Okay, let me try something different here. I'm gonna do a stop sharing. I'm not sure. All right, I'm gonna try something different here now. If I do it this way, try something different now. Because I only have one screen here, but I'm going to try something. Let me see if this works. Can you see that? Can you see this? How about this? Okay. Now the only thing, I have lost my visibility of you. So it don't raise your hand, because all I can see now is my entire screen is this slide. So if you have a question, you're going to have to ask Raphael, or yeah, make yourself known for a question. Okay. Okay, so we ended up right about here. We're talking about just the different concepts. And once you're known in a system, you register yourself in a system. Once you're known in that system, you can now start using your telephone. You can now start using your phone. You can move around. You can receive calls. You can place text calls. You can receive text calls. Your A copy of your profile, a copy of all of your services that you have in your, you might have any services like call forwarding, call waiting, is all going to be known by the visited system. So the visit system knows everything about you, plus the home system, called this home register. This home system knows where you're at. It doesn't know you down to the cell location, but it does. So you already did this part, right? Yeah, this is just a review now. So now we're going to spend some time talking about the mobile telecom industry, just an industry as a whole. We looked at the basics. Next, we're going to look at the mobile telecom industry. After this, then we'll take a look at the different identities that are needed to make a mobile. And then we're going to talk about the different generations and what is it, 2G to 3G to 4G and so on. But right now, before we go do anything else, I think it's important to understand just who are some of the key players in the industry. There are different groups that are called mobile operators. This would be like MTN, Mobile Telecom Network. There's virtual operators. There's not only network operators, there's virtual network operators. There's different providers of services. Sometimes, like let's say, for example, for roaming, in order for you to roam in another network, there's a lot of signaling that needs to take place between those two networks. There's a lot of messages that need to go need to go back and forth. It would not be, and let's just say for the sake of argument, there's 200 mobile network operators in the world. There's more than that. Let's just use the number 200. It would not be feasible for all 200 operators to communicate directly with each other. That would just be impossible. So what they do is they form groups that perform things like signaling. So there's maybe several providers of signaling. They all communicate with those several providers, and those several providers talk to each other. So that prevents everyone from having to communicate with everyone else. There's different data and financial clearinghouses, and we'll talk about why that's necessary, why you have to have a clearinghouse. There's many different vendors. The company that I work for, Cellusys is an industry vendor. They provide services. Some of these vendors provide hardware. Some of these vendors provide software. Some of these vendors provide value-added service like firewalls and maybe analyzers, things like that. There are various aggregators. That's kind of a telecom term. An aggregator is one. Well, we'll explain when we get what that is. But what an aggregator does is instead of having many people all communicate with the network, they all kind of funnel into this aggregator. So that the mobile network's not listening to everyone. We'll explain why that's useful. There's a lot of trade groups and industry organizations that for the benefit of the members, they wield a lot of power in the industry. There's also standards bodies. The fact that you can purchase a mobile phone in Accra and you can fly to Dublin and that phone will work, that means there's standards. So the same frequency, the same network structure has to be in both places. There has to be common yeah, but usually most people, they see maybe a cell tower and they see they're from the scenes groups that make the mobile telecom industry really work. This is a little bit of an old slide. It's a couple years old, but it does show a trend. This is a trend. This particular one is from the United States, but it's typical in a lot of places. It just shows the wireline phones, less and less people relying on the wireline phones, and more people relying on the wireless phones. So somewhere around 2016 in the United States, somewhere around 2016, the trend was more people owned wireless phones than they had no landline phone. Now, landline phones are not dead. They're still needed for things like emergency calls, which wireless can do, but for privacy, for quality, for reliability. So they're not totally dead yet. I just wanted to show this slide as kind of be aware that, and you probably know it. You probably know many households that only use their mobile phone. So one of the basic concepts of mobile telephony is the whole concept of roaming. Now, what does roaming mean? If you have a network operator, like it shows here on the left, this is network operator A, and then another network operator, I just named it B. And this subscriber whose home network is B over here, she now comes into this network. What does that mean? Well, from the perspective of her home network, she's what's known as an outbound roamer. She's outside of the network. She's outbound. From the perspective of where she's visiting, she's an inbound roamer. Now, when she leaves this network, or anyone leaves this network, you go into another network. There's multiple networks. How does the network really know for you to attach to network A, B, C, D? How does it know if you're Vodafone to try to attach to a Vodafone network? Why doesn't it attach you to an Orange network or to a some other network, that MTN network? So there's different mechanisms how that works. Now, For roaming to work, these two networks needed to sign an agreement. In other words, this network here, A, had to sign what's known as a roaming agreement with network B. They had to exchange information. They had to exchange identities of their networks. They had to agree how much to charge for the purpose of roaming. All these things had to be worked out. And so these companies signed roaming agreements. Whenever a subscriber roams, like let's say this subscriber here, let's say she is roaming on network A and her home is B. Mobile network A will charge B for her use of the network. At the end of the month, she does not get a bill from network A. And if you travel to multiple places, you don't want to see all these different bills in the mail. You want to get one bill in the mail from your home network. But this network will charge every time she uses her phone. This network here on the left-hand side, network A, charges B. Now, at the same time, though, roamers, customers from A that are now roaming inside of B will charge A for that. So at the end of the month, network A owes a certain amount of money to B, network B owes a certain amount of money to network A. Each network will then bill the subscriber. So that's what's known as settlement of accounts. But anyway, that's kind of the whole concept. And this is important. Network A will charge the roamer for the roamer's use of the network, and network B will charge the home network A for their roamer's use of the network. So each network does that. Each network charges the other network. When you roam somewhere, the network you're roaming on charges your home network. But there's billing involved. So this inbound roamer, this customer here, that guy over here on the left, his home network is right here. So he's going to use his phone for voice. He's going to use his phone for short messages. He's going to tap out short messages. He's going to use his phone for data. He's going to do www.anything.com. So the visited network will collect details. They collect details about this subscriber. The visited network then puts these into what's known as a TAP, T-A-P. It's a transfer account procedure. They put it into this format called the TAP file. The visited network will then send that to the roamer's home network and charge this network for this inbound roamer, this roamer to use this network. Now, this network over on the right is doing the same thing for inbound roamers onto that network. So it's kind of a mutual thing that goes on. But these files get transferred back and forth. However, what about different currency rates? One country has a euro, another country has a dollar. What do you do about different currency rates? How about different billing models? How about different time zones? Maybe this subscriber is restricted from using, or let's say he has a different rate on different times of the day. Well, again, it's going to vary because of the time zone. It might be from 2000 to 2400 here, but it's a different time, depending on the visited network. There could be different formats. There could be errors. There could be disputes. Let's say this visited company here sends the bill over here, and this company they say they dispute that bill. No, we didn't. Our roamer really wasn't in your network. We dispute the fact that you're charging us for that roamer. He was never there for that period of time. So there's all kinds of these things that do happen. So these companies, this network will not sit down and write a bill and send it directly to another company. They don't deal directly with each other. Instead, they go through what's known as a data or a financial clearinghouse. Now, there are several of these data or financial clearinghouses. Anecto, A-N-N-E-C-T-O is one. EDH is one. Starhome Mock is is one, Cineverse is one. And these companies work with these other mobile network operators for things like roaming services, for things like settlement of accounts, for things like revenue assurance and recharging and tariffs and any disputes. They handle the disputes. If one company disputes the bill they're getting, it goes through this financial clearinghouse. So one network here does not directly bill another network here. They go through these clearinghouses. These are called data clearinghouses or financial clearinghouses. And there are several of these in the world. That's a part of the roaming. That's a part of how roaming works. Slide I wanted to show, but I guess it's not in here. I'll show it next time. Okay. In fact, the next, yeah, please. I mentioned that Celsius is not a mobile network operator. Celsius is a value added operator. In other words, they perform services. They don't do things like they don't have a radio license to operate. A mobile network operator has to have a radio license to operate. Does that make sense? Okay, sure. Now, when you look at standards, and we'll talk a little bit about standards, one of the things about standards is who actually writes these standards. And by standards, there are different standards in the world. There's standards cover things like how many threads there are in a screw, and so if you buy a nut and a bolt in one place, it'll work in a bolt in another place. I mean, there's standards for everything, and there's no difference in telecommunications. Kind of the high level is what's known as the ITU, the International Telecom Union. The ITU is right under the United Nations. But it's an agency of the United Nations that's responsible for issues that concern information and communication technologies. Now, they are not the only standard body, but the ITU is very prominent. The ITU is made up of the ITU. There's three different areas: ITU-D for development, ITU-R for radio, and ITU-T for telecommunications. So certain standards, not every standard, but certain standards get written by the ITU. I don't know if you've ever heard of like Signaling System 7, SS7. That's a standard written by the ITU. So they write standards, but underneath them, there are more regional standards groups. Two of the primary ones in the world are ETSI, the European Telecom Standards Institute, and ANSI, the American National Standards Institute. These two groups write many telecommunication standards. Now, ANSI writes more than just telecommunications. They write standards for many products in the world, but among them, would be telecommunications. So these two groups, though, have regional interests. So when you look at standards for European telecom standards, ETSI and ANSI, there are more similarities than there are differences, but there are some differences. There are some differences between them. Another group that writes telecom standards specifically is called Third Generation Partnership Project. It's 3GPP, Third Generation Partnership Project. There was a second group called Third Generation Partnership Project 2, 3GPP2. These are partnerships that provide standard for mobile technology. Now, we'll talk more about this later, but as mobile telephony was growing, especially back in the 1990s and early 2000s, there were multiple types of mobile communications you could get. There was different air technologies, there was different modulations, there was different communication. Each one was competing for, well, for dominance really in the world. As it turns out, the European model, which was called GSM, the European model kind of won out. And that European model formed what's known as 3GPP. We're going to talk more about this later. But just keep in mind that 3GPP, Third Generation Partnership Project, is the group that writes most, not all, most of the telecom standards today. Now, they named themselves 3G, third generation, even though today there is fourth generation and fifth generation. They still are called 3G, third generation partnership project. The second organization, 3GPP with the numeral 2, that kind of went away. That was competing and that went away. So today, this is the primary standard for mobile telecom. Mobile telephony today follows the standards of 3GPP. A lot of standards. The way the radio signal modulates, the way the communication path goes, those security, quality of service, coders, decoders. There's hundreds, if not thousands, of standards that are written by 3GPP. This is a regional standard, TIA, the Telecommunications Industry Association. We won't mention too much about that. That's kind of more ANSI, but that's another organization. This is an important one. The IETF. What is the IETF? It stands for the Internet Engineering Task Force. There was a time when when ETSI, standards groups like European Telecom Standards Institute and ANSI and ETSI, they did all the standards for telecommunications. The Internet Engineering Task Force was involved with the standards for data, things like IP, TCP, UDP. All of your IP-based protocols were written by the Internet Engineering Task Force, and the telephony ones were written by 3GPP. Today, your phone is very, very much used for data. So a lot of the standards today in your mobile telephone come from the IETF. So a lot of the protocols, a lot of the standards. Today, telephony is not just voice. Today, your mobile telephone is very, very, very much data, as you know. So the standards that were written for data by the Internet Engineering Task Force are used in mobile networks, used in 3GPP networks. We won't go through all of these, just a couple I want to mention. This one right here, the GSM Association. The GSM Association, I want to read this out. It represents the interests of mobile operators worldwide. And it unites more than 750 operators and over 350 companies that are members, like Celsius is a member of the GSMA. Now, they don't set standards. However, they have enough political power. I don't know if that's the right word. They have enough, there's strength in numbers. So when you have everyone belong to the GSMA and they want some more security, or they want different specifications, they don't write the specifications, but they yield enough power to get these specifications written the way they want. So it's not a standards organization, but it is a trade organization. Another one is IEEE. We'll talk a little bit about IEEE. They came into the mobile network environment a few years back, and they kind of exited almost as quick as they came in. But these are just some of the trade organizations that are out there today. So let's take a look, before we leave for today, let's take a look at mobile network operators. What is a mobile network operator? First of all, we need to identify that in a mobile network, whether it's what they call a second generation system, or a third generation, or a fourth, or a fifth, and soon to be sixth, there's always three different pieces or parts of the network. Now, it changes with the generations, but there are three different parts. One is called the UE, the user equipment. In the old days, years ago, that was a mobile phone and a SIM card. Today, it could be an IoT device. Today, it could be a laptop. It could be a tablet. It could be any type of device that connects to the network. That is called a user equipment. The other major piece of equipment of the three is called the RAN, R-A-N, the Radio Access Network. Now, the Radio Access Network uses the radio on this side and it connects up to this third part. That's called the core network. So the radio is responsible for the modulation. It's responsible for everything. It's responsible for the communication from this mobile into this network. The core network is made up of the switching equipment itself, the mobile switch, and it's made up of various databases and various registers. It changes over time, and we're going to look at that the last part of this lesson. We're going to look at different generations and the different parts to a generation. But the core network is what communicates with the rest of the world. In Ireland, there are three major companies, one called Vodafone, one called 3IE, and one called, I think this is EIR. Here in the United States, or when I'm back in my home in the United States, there's a lot of companies, but there's three major ones: T-Mobile, AT&T, and Verizon. So those are called mobile network operators. They own the core network. Now, what makes up this core network? Well, first of all, you have a core network. They also, this mobile network operator not only operates this core network, it also operates the signaling network. In other words, this network not only talks to itself, but for roaming purposes, this network has to talk to all these other networks. Every time you sign a roaming agreement, you need communication between them. It's also responsible for doing any interconnection, any roaming agreements, working with these financial and data clearing houses. It also is responsible for services. It's responsible for your voice service, your short message service. It's responsible for what's known as SS, or supplementary services. Supplementary service, that's something like call forwarding or call waiting or three-way calling. It's also responsible for having subscribers access the network. It's responsible for routing. When you place a call or you use your phone for data, that information has to be routed. It's also responsible to interconnect with other networks. Different things like customer care, billing, marketing, 4G networks. So it's responsible for these. One of the key things a mobile network operator has, though, that other types of network operators don't, it has this part right here, the radio license. Now, these frequencies that are needed for radio, remember we talked a couple weeks ago about different radio frequencies in the 800 megahertz range and the 700 megahertz range. In that UHF radio frequency, they have to go to the commissions that in the country and get permission to use those frequencies. You can't just use someone else's frequency. You can't just grab someone's frequency that's being used by someone else and just, if you tried to use that, it would block everyone else out. So you have to have permission to use that. So the mobile network operator has gone to the various government agencies in their country, and they have permission to use the frequencies, use those radio frequencies. And that's this band right here. Let me go back to here. That's this band right here. Most mobile telephony is in what's known as the ultra high frequency band. It starts at 300 million cycles per second, all the way to 3,000 million cycles. So 300 megahertz, 3 gigahertz. That frequency range is very, very desirable. Most mobile telephony operates in that frequency range. So these mobile network operators, they have permission to use those exact frequencies. So that's a mobile network operator. And I think this is a good place to end it for the day, because we're going to look at different operators. Let me just go, we'll only go 2 more slides and we'll end it. Around the world, mobile network operators, these are the large, for the most part. Most part, these are large companies. One of the biggest ones in the world is MTN. MTN is Middle East, it's Africa. There's other ones, but MTN is a big one. Vodafone is a big one. AT&T is a big one. Bell Mobility is a big one. Oi in Brazil is a big one. Telecom is a big one. So there's a lot of big operators in the world. These are mobile network operators. They have the radio, they have the core network, they have all the things here that make a mobile network operator make it so it can operate. Here are the largest MNOs in the world. So here's telegeography, this website right here. Largest one in the world, at least according to them, is China Mobile. So you can see the top ones in the world are China and India, just the sheer concentration of people. So these are the largest ones right here in the world. And there's several, Indonesia, the large one also. Then there's several here in the United States, Indonesia, Japan, Bangladesh, and so on. So these are the largest ones from as far as the total number of subscribers. MTN is huge. It doesn't have as many subscribers, but it is a huge network. So those are what are known as mobile network operators. Now, when we meet next week, we're going to look at other things like virtual operators. So some operators are what are known as mobile virtual operators. Any questions? This is, yes. Let me.
I have one question, just a quick one. Yes,
yes.
About the roaming communication, that is the roaming. For instance, if I'm using MTN in Ghana and I'm using the same roaming and I'm in UK, we're talking about the billing system. That is, how do I, unlike in Ghana, we recharge your phone. Okay, so
you're talking like a prepay system.
Yes.
That's up to your home network. Your home network is in charge of that. Whenever you have a service like prepay, that's what's known as an intelligent networking platform. That's going to be that billing has to go back to the home system. The visit system is going to send that immediately. Once you have that type of intelligent networking, that prepay service, that goes back to your home system. Because you're right, you're absolutely right. That's a good point. The visit system doesn't know anything about your prepay, how much money you have. You might have, €5 left. You might have 500. You might have 0 left. The visit system, when you're roaming, has no knowledge of that. So that has to communicate back to your home system.
Awesome. So how was our network structure? Mr. Joey, can show you
Anyway, thank you very much, and I will see you. I'm going to go to bed now. Back when I was back home, I'd be eating lunch right now. There's Joseph. I'd be eating lunch right now. But instead of eating lunch, I'm going to go to bed right now. So thank you very much. We'll see you. We will see you next Wednesday, though. My plan is I'll let you know if it changes, but I plan to meet next Wednesday. I want to keep this going. I don't want to take a break here. I want to keep this going. Okay, say hi to Richard when you see him. Okay, cheers. Bye, everyone.